Will it rain anytime soon in California? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 19th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype. If you enjoy the video, give us a thumbs up. If you haven't subscribed, click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. B Hall B, Tim Caston, Brandon Campshire, Clay Goose, Gabby AM, Our Predicament, California Weather Watch. He actually has a good channel. You want to go take a look at that. It's daily weather updates for the whole U.S. West Coast. And Danny S. Gluck. Thank you all so much. I appreciate it. With that, let's get to work. We'll start by looking at significant wave heights across the planet. Starting in the North Pacific, we actually have yet another gale with 26, maybe 27-foot seas on the date line, pushing off to the east. That on top of, you can see already a good amount of swell in the water pushing towards the U.S. West Coast and, of course, Hawaii. Down in the South Pacific, pretty calm pattern, as would be expected for the time of year. North Atlantic, another pretty good gale with 30-foot seas targeting, looks like Morocco and that area, and probably at some point up into Europe. In the South Atlantic, pretty quiet, again, as would be expected. Then over the Indian Ocean, pretty good gale, again, organizing, providing a steady diet of small but decently long period surf for exposed breaks up into Sumatra, Bali, Western Australia, and that area. So hope is not lost on the surf scene. But before we get into all that, let's take a look at current conditions. We're going to look at the buoys. We'll start up in Pacific Northwest, Grays Harbor there off of the Columbia River, buoy number 036. We're looking at all the energy that's hitting the buoy, all the way from up here, super high, very energetic swell periods, 33.3 seconds. Yes, we have 1/10 of a foot of energy. Now, that's not really surfable, but you see as you work your way down in the 16-second range, there's still 3.7 feet of energy right in that band. And then when you're actually computing pure swell, it's a mixture of all the energy on both shoulders of that peak to derive the pure swell, not including like wind chop down here at 5 seconds or anything that might be some other swell way up here. So you see the spike at 16.7 seconds. And as not unexpected, primary swell 4.8 feet, 16.9 seconds from 269 degrees. Theoretically, that makes surf at 8.1 feet. And then there's some secondary swell in the water, 2.9 feet at 13.8 seconds from 271 degrees. Theoretically surf at 4 feet, but my guess is all this is sort of all related. Oh, the chop height here, 0.6 feet. That's really low. And this is not, yes, it is all the energy that's present between 2 and 5 seconds, but uses kind of as an index of how clean or junked up the swell is. 0.6 feet, pretty clean. In fact, pretty pristine. Then we head down south a bit to Point Reyes, California, buoy number 029, just there off of Point Reyes, north of the Golden Gate. We see basically the exact same profile, but with a bit more energy stacked in and another little hump out here at 20 seconds. So multiple pulses of energy interacting. Primary swell, 5.3 feet at 17.2 seconds from 283 degrees. Surf from primary swell, 9.1 feet. Well, I just got out of the water. I would say there were double overhead sets, but the frequency was literally one set an hour, if not more than that. Top spots were doing bigger than that. But again, hour and a half wait for sets. There was one set that came through. I kid you not, it lasted for 10 minutes nonstop I verified that, actually measured it, and there were 18 waves in the set, but that was one set pretty much out of the entire day. So most of it was one set with 3 or 4 waves every, hour or so. And then secondary energy, 2.2 feet at 20.6 seconds. Again, that is just shoulder energy out here. All this is pretty much the same swell. Chop height, 1.1 feet. Yeah, that seems about right. It was not junked up, even though there was some northwest wind on it. Still quite rideable. Going to Southern California, the Point Loma South buoy there off of basically San Diego, buoy number 191. Now we're seeing this is about a day behind. So the description of what I gave, what's happening in Northern California, that's pretty much what you can expect in Southern California, like late tonight or into early tomorrow morning. We see that one peak there, 20 seconds. At 1.8 feet, and not a whole lot else of anything going on. Now, of course, you have to contend with the Channel Islands that shadow the swell. This buoy is behind the island, so it is shadowed, the angle to north. 2.2 feet at 19.7 seconds from 278 degrees. I mean, the actual swell direction up in Northern California was between 292 and 294 degrees. Literally, that's measuring the center of the storm, drawing the great circle path into Northern California. And it was like 292 to 294 degrees. Add about another 5 degrees on that for Southern California. And you're into the upper 290 degree range, which for the most spots in Southern California would be shadowed. Anyway, surf from the primary swell, 4.3 feet. Then there's also some shoulder energy in there, 1.4 feet at 16.2 seconds, but I'm going to ignore that. Chop height, 1.1 feet. Yeah, it's clean. I mean, not unexpected. Then we go over to the north shore of Oahu, Waimea Bay Buoy number 106. This swell hit there first about 2 days ago and is starting to settle down now. 14-second period energy. Hopefully the consistency is up a bit. We'll talk about where this swell came from, but Hawaii was closer to the source, so it would not be surprising. There was more frequency of sets and a little bit less of a wait in between sets. Primary swell, 5.1 feet, 13.7 seconds from 320 degrees. Surf, 7 feet, theoretically. We'll call that 7-foot Hawaiian, though. And then some wind swell in the mix, 3.5 feet at 10.3 seconds from 327 degrees, adding another, well, it's probably 3.6 feet of surf buried under the larger swell. And the chop height, 2.4 feet. We'll see. I didn't actually get a chance to go look and see what was happening in Hawaii, but theoretically a little bit bumpier and lumpier. All right, so let's do our Hindcast review. What has been going on in the North Pacific for the past week? We're at Monday, January 13th. Little gale there started winding up off of Japan, building with seas in right here, 35 feet. These are the highest seas over this entire domain. And here's the location, 35.5 north. So, yep, that'd be about right. 154.5 east. Yep, so that is it there. So 35 feet, we'll step through this. Building a little, 34 feet, 36 feet. In fact, I'm not going to go through it. This is, regardless, this is the storm that made the swell that passed Hawaii a couple days ago and peaked out in Northern California today and will be peaking in Southern California in the morning on Monday tomorrow. You see good energy. Here we go, 41 feet. I think we got maybe a 42 foot. Nope, we didn't get 41 feet was the peak of it. The date line right there, about 2,400 nautical miles out from the U.S. West Coast. Passed over the date line, quickly faded. But secondary energy started building on the date line on, this is Thursday night, the 16th of January. Now, not as big, 28-foot seas. But I mention this because, well, you'll see when we get into the spot forecast, there is a lot of energy in the water, and you can see it just pushing off to the east, pushing into the Hawaiian Islands, and that should continue for a while. Now we're into Saturday, yet another gale developed behind that with 28, 29-foot seas. Here we are Sunday. It's approaching the date line, And oops, that was it. That was the last frame of the model with 27-foot seas poised to go over the dateline. So basically 1, 2, 3 swells. They're all going to kind of probably more or less blend into one another and just make a steady run of surf for the entirety of the coming week. So there are waves to be had. Now we go down to the southern hemi. I mean, it is winter up north, so we would not expect a whole lot here. There's Sunday, Monday. We're into Tuesday, the 14th of January. We're just running through this real quick. We're looking for anything with 28-foot seas or higher. 28-foot seas would be that dark shade of red down there. I mean, the reality is I wouldn't expect to see it. Here's our latest run of the model, and nothing. So quiet in the southern hemi. Then we go to the North Atlantic. The pattern has just been the jet stream just ripping off the U.S. East Coast, heading off to the northeast towards Ireland and to a lesser extent Europe. So last Sunday we had a gale here with 42-foot seas. That raced off to the northeast, and you just see this machine one after the other. Doesn't do much for producing surf on the U.S. East Coast, but anywhere up here in the target zone for sure. Another gale with 32-foot seas following the same pattern. Yet another one. Now, this one took an aim a bit further south, and this is, as of right now, that is 33-foot seas targeting anywhere, I'd say, in this range right here. If you live there, you know where to go. The South Atlantic, again, sort of like the South Pacific, but whoa, look at that. We're into, this is Monday the 13th into Tuesday the 14th of January. A pretty solid gale with 39-foot seas pushing well off to the east, not aimed to the north very much, but still that much. And there we go. Then it finally did. I mean, I don't know exactly what happened in South Africa, whether they got swell from this, but it certainly looks like they should have, and it should have arrived a day or so ago. Let's go just roll this out, see if there's anything behind that. And no, pretty quiet after that. Still, good late season pulse. And then the Indian Ocean on Sunday, a gale with 28-foot seas built with seas up into the 32-foot range, kind of hovered there in the south central Indian Ocean, then pushed off to the northeast, producing swell. You see the swell foot front hitting Western Australia. This is on Friday, and let's see if we can actually see when it arrived up into, well, right about there, into Indonesia. That would have been today, basically, as of current time. Another gale building with 34-foot seas. So Indian Ocean still providing swell. So let's do a deep dive for the North Pacific and see what is coming. We're going to start by looking at jet stream level winds. These winds are up about 30,000 feet. They help support the formation of gales, and when those gales form, the jet stream helps direct their track. We're looking for a trough, a dip in the jet. You kind of see it right there. You kind of see it right there, but not super pronounced. What that helps do is create a counterclockwise flow aloft in the atmosphere, up at jet stream level wind area, but also down at the ocean surface. And that is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds on the ocean surface. Those winds get traction on the ocean surface, producing seas. Those seas, as they radiate away from the fetch area, the lesser period elements of the seas decay out, exposing longer period swell. Of course, swell, when it hits your beach, turns into surf. And that's exactly what we have going on in Hawaii and along the U.S. West Coast right now. From that gale with 40-foot seas that was over here near the dateline a couple of days ago. All right, so now looking at the jet stream, it is still consolidated. That is good for building troughs. But notice wind speeds are down considerably from where they were 2 weeks ago, 3 weeks ago, 4 weeks ago, when winds were 180, 190, at times up to 220 knots, whipping off of, well, here's Japan and the Philippines here, off this area. And then you see the jet splitting here north of Hawaii, about 900 miles north of Hawaii. It's actually a little northeast of Hawaii today. But then you get that split where part of it's going north, part of it's going south, and you get this clear air in between. That just sets up high pressure. High pressure blocks rain from coming in. To get rain into any of these areas, speaking to the title of this video, the jet stream really needs to be pushing into the coast, or Here you kind of get the sense of maybe a backdoor trough trying to push in, but I think it's going to end up being dry and not a whole lot is expected from it. So let's just put this into motion. There you can see your backdoor trough inland, maybe for Utah and Colorado something, but for California, I would think not. Consolidated Jetstream, split right here, the two flows. That has been the hallmark for the past couple of weeks, and there you go. There is the prime example of it. Notice this really deep trough setting up north of Hawaii on Tuesday night into Wednesday. That should support low pressure development there, local low pressure. It just sort of holds, if not getting cut off. We also see some sort of a trough trying to develop off the Kuril Islands. This would be on Thursday night, Friday the 24th. And that, there you go, there's your trough there. And look at how big the split gets. Notice backdoor trough trying to push over San Francisco. I don't hold any significant hopes for that being some major weather producer of any kind, much less down into Southern California, but we'll have to see on that. And that's the end. And you see, if anything, 180 hours out, the jet is kind of losing definition, if anything. And we'll explore some of why we think that is happening and what we think is going to happen, maybe beyond. This goes out a week. It's really, let's go look 2 weeks out and 3 weeks out and see if there's any hope for rain into California and get a sense of maybe what the swell machine's going to do. To produce surf, you need winds blowing on the ocean surface. Right now we have a gale, minimal gale, 35 knot winds, the yellow color here, 35 to 40 knots. Yes, it is a gale. Approaching the dateline. The dateline's right there. That's the Aleutian Islands up there. Generating some seas. We saw that. And it is forecast to push over the dateline as we get into Monday. Actually, winds build a little bit to 40 knots. And then it continues off into the northern Gulf and fades out as we get into late Tuesday. Another gale is forecast somewhere here near the North Dateline region, but not particularly well defined. Now this is actually a new feature on the charts as of late Wednesday. Look here, we know that there's a steep trough right there. Forecast with a gale. I'll actually pull this away here so you can see 45 knot winds right there, aimed right at Hawaii and all of 600 nautical miles away. So perhaps some pretty energetic local north swell, but probably pretty raw and probably, well, it looks like northwest winds coming into the Hawaiian Islands. So you'd have to find some magic little protected break to get rideable surf out of that. And after that, also notice, in fact, let me go back just a little bit, 1040 millibar high here with isobars going the whole way down off of Baja, Mexico. I mean, that, if ever there was a massive blockade for weather energy, that sure looks like it. 1040 millibar high, pretty impenetrable. And then you see this north wind thing going on off of north and central California. This is almost a week out. Saturday, this would be the 27th of January, and then a return to likely an offshore flow. Also notice some broad lows setting up here off Japan. And that still, is this low the continuation? No, this is another potentially low developing north of the Hawaiian Islands on Sunday. So definitely not the same pattern that we've had, kind of more localized, bit more broken up, not just the Jetstream train just roaring across the Pacific, setting up for more, call them local storms, not moving so well, not big monstrous swell producing things. We'll just have to see how this plays out. This is kind of new on the charts. Anyway, you get the idea. So what is the effect of those winds on the ocean surface? We could have winds, we could have the jet stream, we could have all that stuff, but ultimately the winds have to get traction on the ocean surface and generate seas. So as we saw before, 27-foot seas approaching the dateline today into tonight. By Monday morning, still 27-foot seas pushing over the dateline. That's good for like 15, 16-second period swell, likely down into Hawaii and the U.S. West Coast. Hawaii may be larger in size just because they're closer, and California, well, a bit further away in the Pacific Northwest. So swell will decay some, and that gale finally fades out as we get into Tuesday night, and then nothing. Behind that, here comes the local low relative to Hawaii. I am purposely ignoring this because notice the arrows and all the fetch. It's targeting the Aleutian Islands, and that's it. So we have 20, 22, 24-foot seas in close proximity to Hawaii. I mean, that's not particularly huge, and that's what, probably about 600 nautical miles away. Still, swell into the Hawaiian Islands. You see some sort of wind swell going on here relative to California on Saturday, the 25th of January. We're almost a week out, and then here we are, 168 hours, 174, and yeah, another little something trying to organize, but it definitely looks like the swell pattern is fading. We have a bunch of swell in the water, a little bit more being generated for a day or two. Then after that, things kind of start mellowing out. So let's explore other locations around the planet, starting in the South Pacific. We're going to run through this pretty quick because, well, oh, actually, look at that. I didn't notice that before. 34-foot seas going to 36-foot. Aimed well to the northeast, so our friends in Chile and Peru, and maybe even up into Central America could see some swell from that. I mean, all this is, well, the cutoff for Southern California is like 117 west. So this is a South America swell producer, and that's within the 72-hour window. So the reality of that happening is actually pretty good. And you can literally see the swell impacting the coast, working its way up the coast. We're out onto Thursday and Friday and even up here into Saturday. So something to look forward to if you live in South America, but relative to Hawaii and California, no hope. Next up, the North Atlantic, and there is, so this little gale that we noticed here with where we get the seas up to 33 feet. Yeah, that was about the peak of it. 33-foot seas, targeting this area right here, and even probably even into Portugal to a certain degree, but there'd be more sideband energy. It's really the direction of the winds, the direction the winds are moving towards. That's really what dictates where the majority of the swell ends up. Now, that is somewhat interesting, but as we get into this further out on the models, now there's another one, here we go, with 38-foot seas, right, you know, just directly impacting that area. So probably not, but there is another one if I saw, here we go. Now this is almost a week out, but this is a impressive storm, 42-foot seas, building to 51 feet, building to 56.8 feet. Now that is equivalent to the storm that was off California at Christmas and made the theoretically 108-foot wave that hit Mavericks, and targeting directly Portugal. You know where the big wave spots are there. Now, relative to up in here, a little bit shadowed by that land, but let's see, we'll pop this up one more, and what do we get to? 59.5 feet. I mean, that is incredibly large. It's a week out. Do I believe it? Of course not, but the models have actually done a reasonably good job, at least giving us a heads up of things that are coming a week out. So that's something worth keeping your eyes on, especially if you're in Europe and you're a big wave surfer. The South Atlantic, we'll go through this pretty quick. I don't think I tried to review most of this stuff ahead of time, and I didn't think I saw anything. I mean, we're just blasting through because the whole week, here we are Saturday and into Sunday, the 26th of January, and nothing, and obviously forecast. And then finally, the Indian Ocean. Little gale there pushing across 30-foot seas. This is some sort of tropical activity. I don't know the name of it. I'm really not following it that close. So there you go. And then one little other system here. We're 180 hours out, 27-foot seas. So more or less relatively quiet for the Indian Ocean. Local wind forecast. California here, so this would be Southern California, Central California here. There's the Golden Gate, San Francisco area, Northern California, up into the Pacific Northwest. A light, moderate offshore flow for Oregon, we'll say, and a light offshore to bit northwest flow. This is Sunday for California, and more or less trades, east-northeast trades, 15 knots for the Hawaiian Islands. As we get into Monday, offshore flow continues for California, and that instead of a pure trade, because of this low pressure here, that's more of like almost a northeast wind pushing into the Hawaiian Islands. Tuesday, a continue of that. Fortunately, it's weak. High pressure continues off the Pacific Northwest, light offshore flow for California. Wednesday, again, more offshores as high pressure starts pushing into the Pacific Northwest. You see a southwest to a south flow for the Hawaiian Islands. And there you go. Here's your building low pressure, but also you see building north to northwest winds sweeping over the Hawaiian Islands. Offshore flow for California, but I don't see, I mean, I have to go drill in. Actually, we'll go take a look at that in a minute, the Southern California local forecast. Here we are Thursday, Friday now, 10:42, impenetrable high pressure sets up. It too, notice the clockwise flow around high pressure, generating strong north winds at 30 to 35 knots for Northern California. That's wind swell. You see here onshore flow for the Hawaiian Islands at 10 knots. That's on Friday. On Saturday, still, now this looks like somewhat of a building northeasterly flow for North and Central California, but still 20, 25 knot north, almost northwest winds over outer waters. There's going to be a bunch of lump in the water. And you get this light, you can see it just, there's low pressure here and this light draw up over the Hawaiian Islands out of the southwest. Then we're into Sunday, a week from now, and another low pressure building, certainly able to produce, well, what is that, 35, 40 knot northwest winds targeting the Hawaiian Islands well, but not the U.S. West Coast at all. High pressure holding at 1034 millibars off the coast. All right, so this is Southern California, San Diego down here, Huntington Beach, Dana Point, Santa Monica, Point Dume. You get the general idea here. High-res wind model. This was as of 11 a.m. Sunday. Light onshore flow for the northern part of Southern California and pretty much calm winds further south. According to the model, you see the onshore flow built a little bit in the afternoon. Now, this only goes out 2 days. It goes out 84 hours. So we'll fast forward into Monday. Here is the building offshore flow, not particularly strong. We're talking, what's that light shade of blue? 8 knots. But you know, in certain canyons here, the orographics tend to enhance wind speeds. And there you go, 11 a.m. Monday, and we're into 20 plus knot offshore winds. That's like nearly 25 knots or 25 miles per hour, maybe higher. This doesn't include all the orographics and offshore there. So Monday morning, oh yeah, into Monday afternoon, not looking good. And then Monday evening, dangerous conditions for sure. We're into Tuesday morning and we're into 25, maybe 26 knots, 30 miles an hour, and just eyeballing it, I'd say maybe 50 or 60 knot gusts in the canyons. Again, and that's not only Point Dume area, but all the way down into more Dana Point and Orange County area. That continues into Tuesday, starting to moderate. By Tuesday afternoon, well, we still have an offshore flow, but much decreased from before. Wednesday, continuing now, way more moderate, we'll call it 12 to 14 knots offshore, limited to the Point Dume area. Still something to be aware of. We're looking for an onshore flow and precip, but, well, let's go look at the precip model. So again, this is a backed off view again, Southern California here, Central California, North California. We're looking for any shade of blue, no matter what you get coming into California. And I'll just click through this. So here's Monday, nothing. Tuesday, and notice the pattern here. So this is like Whistler right here, Oregon. See if can't even get snow or rain into Whistler, and we're into Wednesday. Thursday, there we go. A little bit of frozen and liquid precip, not even into the there we go, into the U.S. Washington gets a little bit on Thursday night. And does it make it any further south? Doesn't even make it to Oregon. 1040 millibar high, just completely locking everything down. Now you get the sense that maybe with the backdoor front here that maybe something might dribble down the spine of the Sierra. I mean, it's not really showing it here. We got one more chart we'll look at, but for the most part, for the next week, California looks to be high and dry. And honestly, if you're trying to do skiing anywhere in this area, a continuation of the lockdown driven by just bulletproof high pressure, a split jet stream flow, the jet stream not strong enough to power east and just wipe out this high pressure system. In the long-term part of the forecast, we'll look at the potential, and these are just best guess odds at whether something will change and break this lockdown pattern that we're in. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley, on the 25th of January. We'll call that an inch, maybe 2 inches of snow. That is dubious at best, and otherwise just nothing. And I'm not even going to go look at any of the resorts because I don't think it's any better. The freeze level. All right, so today is the 19th. This evening, oh, I'm sorry. This is the base of Palisades, Tahoe, 6,200 feet. This is the summit at 9,000 feet, top of Granite Chief. Good proxy for pretty much what's going on in most of the Sierra. You see these reds, these are above freezing temperatures. The gray is sleet, still not even freezing. The freeze line starts where you see white. And as we get into tomorrow at about mid-morning, the freeze level is up at 10,000 feet. That continues into the 22nd, if not building up to 12,000 feet. Now, this is new on the charts, this big sort of, and again, maybe this speaks to the backdoor trough. And you see the little yellow lines down here. That's where maybe you could get some snow. The freeze level falling from 6,000 feet. This would be on the morning of the 25th. Theoretically, going the whole way down to 1,500 feet or 2,000 feet. That's probably a bit of a stretch, but you get the sense. And then right back to freeze level going up to 10,000 feet. So no clear sign of a legit winter pattern yet. And this goes out 10 days. All right, so what will the surf be like for the coming week? We'll start up in Columbia River area. That'd be northern Oregon. Surf heights fading from 8 feet today into about the 5-foot range on Monday, maybe bumping up a little bit on Tuesday into the 7-foot range as another swell hits, and that slowly fades. But you get the sense of nonstop surf at least into Thursday, and then yet more building swell into the 12-foot range on Friday, and then drifting down through the weekend, only to rebuild a little bit later in the weekend. So no shortage of surf, but also notice here a bunch of northwest winds, 20 to 23 knots, and even over into Saturday. That's northeast at 20 knots. So a little bit of a chop pattern here, but otherwise, just looking at the arrows the whole way down along here, offshore winds for the entirety of the bulk of the work week. Swell sizes, okay, from 5 feet at 16 to 17 seconds today. Monday is settling down into about the 4-foot range at 14 seconds, so much more manageable. Another pulse of swell hits, 5 feet at 14 to 15 seconds, that'd be on Tuesday, then slowly working its way down. Another pulse of energy, 3 feet at 16 seconds, and then building up to there, 8 feet at 14 seconds, continuing on. So a good amount of swell through the 7-day period. We go down to Northern California, Ocean Beach, that'd be the San Francisco area. Monday, surf heights in the 6 to 7 feet. slowly fading on Tuesday, still about 6 feet. Wednesday, 5 feet. Thursday, 3 feet. And then, well, we see surf heights of 16 feet. When you see these big dropouts, that says a bunch of wind swell. And look at the winds, 30, 34 knots out of the northwest. So that's all just garbage. And then it fades down from there. Let's go take a look at actual swell sizes. Maybe that gives us a clue as to what's going on. So for sure, the front end of this swell was considerably bigger than what the models said it would be. That's a little trick you got to know about the models. Anyways, we get into Monday, 4.3 feet at 16 seconds. Tuesday, say 4.5 feet at 15 seconds. Another little pulse of energy comes in, just continues slowly fading down, but still legitimate swell the whole way into late Thursday. And then we get our wind event with 15 feet at 10 seconds. Yeah, that's just all pure wind swell, and you can see it right in there. Fading out at 7 feet at 12, 11 seconds. That's probably all just residual wind swell too. San Diego, the same pattern, but a bit attenuated by the Channel Islands, and also the wind swell appears to be blocked a bit, which is actually a good thing. Anyway, surf heights 3 feet as we get into Monday, working their way down to 2 feet on Tuesday, 2 feet Wednesday, and then settling down below thigh high or less on Thursday. Friday, coming back up for the weekend into the 2 foot, 2.5 foot range. But also notice this is west winds at 20 knots as we get into Saturday. And otherwise, the offshore flow here, best using the high-res model that we saw before if you really want to know what the winds are doing. The GFS model is just, the grid scale is too big. Each grid square is like 60 nautical miles by 60 nautical miles. Great for doing surf forecasting, in terms of raw swell production, but not for local sorts of weather projections. All right, so swell heights 1.6 feet, 17 seconds on Monday, fading to 1.5 at 15 seconds on Tuesday, 1.5 at 14 seconds on Wednesday, Thursday down to 1 foot at 12 seconds. Tries to come back up, but we're still talking 1 foot at 14 to 15 seconds, and then pure wind swell after that. The North Shore of Oahu, closer to the action. Yeah, swell is already fading there as we get into Monday. Still 7 feet, but trickling down as we get into Tuesday. Wednesday, things come up as the next pulse of swell arrives from 8 feet up to 13 feet. Now, some of this is that north local swell as well. In fact, probably most of this is, and you can see the local winds northwest at 20, northwest at 12 sort of thing. Then trades finally settle back in for Friday, still with a little bit of a northerly component as surf heights fall from 11 feet and dropping from there. Swell sizes, 5.5 feet at 12 seconds Monday. Tuesday, even less. Wednesday, another little pulse energy comes in, but building from a more northerly direction, 5, 6 feet. And then at dark, 9 feet at 13 seconds, building to 10 at 12 seconds from 341, 346 degrees. All this is local swell for sure the whole way out after that. Quick look at Ireland just for fun, since they seem to be the target of all the energy. Really nothing happening until you get into Friday, and then surf heights into the mid 30-foot range. You also see west winds at 50 knots at times, so probably pretty raw indeed. And then things settling down from there. Swell heights 27 feet at 14 seconds, certainly big regardless. With our remaining time, let's go take a look what's going on long term. What's going on from a long-term outlet perspective, and when you look at the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation, these two weather oscillations seem to be the biggest influencer on surf and weather in the Pacific Basin long-term. So we start by looking at the MJO, the Madden-Julian Oscillation. As you all know from watching this video in the past, there are two phases to the MJO, the active phase and the inactive phase. They rotate around the planet, one on one side of the planet, the other on the other. They move from west to east along the equator. when the active phase of the MJO moves over your ocean basin, in this case, the Pacific Ocean, because it is like a low pressure system, takes warm, moist air at the ocean surface, lifts it aloft, that gets caught by the jet stream. It energizes the jet stream, making it stronger, more coherent and consolidated. That in turn feeds the development of troughs, which create storms and surf and weather. The inactive phase of the MJO does the exact opposite. It is like a high pressure system, and it effectively cuts off the flow of moisture. It produces falling air, cuts off the flow of warm, moist air up into the atmosphere, and then all you get is raging high pressure, sort of like what we're seeing off the U.S. West Coast forecast for the next week, strong high pressure. We get signs of what's going on by how the trade winds in the Pacific are affected by the MJO. That is, the active phase of the MJO, because it's low pressure, trades are generated by high pressure, so that dampens trade winds. Likewise, when you have the inactive phase of the MJO, it amplifies the existing high pressure pattern, and then you get stronger than normal trades. So we look at this data from the TAO buoy arrays. There's a series of buoys. This is the equator right here. This is the West Pacific here, East Pacific here. That is New Guinea there. The date line's right there. We're just looking at the arrows. This is the 5-day mean ending on January 18th. So we just look, are the arrows longer than one would normally expect, and go, these are like moderate, strong trade winds here in the East Pacific, pretty strong trade winds over the Central Pacific, pretty strong trade winds over the West Pacific. But it is not the actual speed that matters. It's the difference from what is normal for this time of year, because trade winds blow at different strengths depending on the time of year. So for this time of year, looking here in the East Pacific, well, look at the arrows. They're like, no, there's no arrows, or they're out of the west. So this says trades are weaker than normal here in the East Pacific. Over the Central Pacific, just about normal, maybe just a little bit stronger than normal. But over here in the all-important Kelvin wave general area, far West Pacific, trades a bit stronger than normal, but not like howling strong. Let's go look at the forecast for the next 2 weeks. Zonal wind anomalies. So this is just saying, are the trades stronger or weaker than normal? The east-west component of the wind. The blues, stronger than normal. The reds, weaker than normal. We want to see the reds get real strong. We want to see the blues get real weak. Okay, but this is for the whole planet. So let's get ourselves oriented here. 180. That is the date line. So that's the core area in the Pacific. Pacific starts at about 125 east, so right here, okay? And then the Kelvin wave generation area, or the more important area, ends at about 170 west in the West Pacific. Now, back in December, when we had all the surf and we had rain, the trades were pretty strong. Very weak. Westerly anomalies were strong over the maritime continent. This would be like Bali in that area. And then since then, the jet stream has still done pretty well, but it's gotten progressively weaker. And notice, westerly anomalies have gotten over this area have gotten progressively weaker as well. A little bit of west anomalies actually pushed almost to the date line, suggests the active phase of the MJO made some headway across here, but it wasn't strong enough to do anything. Normally, this is what you'd look for swell production, but I don't think it really did a whole lot. What I think is happening and what we've been seeing is, and just like what's forecast to start happening tomorrow, or actually, tomorrow, is see these westerly anomalies building and getting stronger, just like they did back in December. This, we think, is feeding energy into the jet stream. As the jet stream moves west to east across the Pacific, it hits these westerly anomalies. That's pumping energy into the jet stream and then feeds it, building stronger across the Pacific, and then potentially driving storms into the U.S. West Coast. Maybe. That was what happened here. The hope is that'll happen again. Now, notice the models only go out like what we were looking at, the precipitation models, they only go out 1 week. So here, and it takes a couple of weeks of this pattern getting going and feeding energy into the jet stream. It takes a while for the machine to get warmed up. But as we get towards the latter part of January and early February, well, you see westerly anomalies building. If anything, that should be feeding the jet stream more. So the thought is this decreasing swell and building high pressure pattern off the U.S. West Coast is attributable to the fading westerly anomalies over the maritime continent. It's all an interconnected system. What's happening over, basically north of Australia affects us over here on the other side of the pond, and we don't live in isolation. Anyway, the thought is maybe once we get about a week out, things will start waking up. Let's keep digging. Outgoing long-wave radiation forecast. So this is similar. The reds are the inactive phase of the MJO, very dry air, right? Okay, that is, if you have high pressure prevents cloud or suppresses cloud formation. So if you have a satellite and you're beaming satellite energy down and trying to bounce it off the ocean surface, you're not going to get a very good return because the clouds are going to suck up the satellite's radar image. So that's what this is saying. And this is South America, Central America, New Guinea there. EQ is the equator right there. The date line right here. So this looks like the inactive phase of the MJO over the West Pacific, with the active phase trying to build in the Indian Ocean. 5 days from now this is the statistic models version. Inactive phase building, active phase building in the Indian Ocean and getting stronger. Notice 2 weeks from now, active phase, maritime continent. This would be westerly anomalies here too, all just setting up, feeding the jet stream as it comes diving over this area, pushing it across and giving it more momentum as the inactive phase of the MJO moves further off to the east. Now that's the statistic model. The dynamic model, pretty much the exact same thing. Let's see if we can get them both we can't do it easily. But anyway, you look at the last frame of the model here from the dynamic model, the GFS model, and then the last frame for the statistic model. They are very similar indeed, and that's about as close as you're going to get for a 2-week forecast. So it seems like this is the pattern coming up. Phase diagrams for the same two models. Statistic model here, dynamic model here. How do you read this thing? Well, the MJO, this is about where the active phase of the MJO is and how strong it is. The MJO active phase moves from the Indian Ocean to the maritime continent, that'd be like Bali, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, and then back to the Indian Ocean. The heavy dot is where the active phase is. The further that dot is away from this circle, the stronger the active phase is. So this is a moderate active phase in the Indian Ocean, moving towards the central Indian Ocean. Now there's 1, 2, 3 different members on this, but notice this one member shows the active phase incredibly strong over the maritime continent. This would be 2 weeks from now. The GFS model suggests, well, it's going to get strong in the Indian Ocean and then collapse to almost nothing by the time it gets to the maritime continent, sort of like these two members are suggesting. So a big disparity in exactly how this is all going to play out 2 weeks from now. The upper level model. So this is interesting. This is up at Jetstream level, areas favorable for precipitation and not favorable. And this really tells us something very meaningful. So here is South America, Central America, maritime continent. Now this runs about a week ahead of what's really going on at the surface because things move faster up at the jet stream. But dry air, bone dry air, this would be supporting high pressure due south of California. And you wonder why there's strong bulletproof high pressure forecast off the U.S. West Coast. I think it might have something to do with this inactive phase of the MJO. This shows it over the East Pacific. The other models show it more back here, but basically they're all showing it working its way across. But at some point, you see the active phase easing its way off the maritime continent. This is January 29th here. Again, this is a week ahead. So maybe as we get into 3rd of February, every 5 days, so this would be the 8th of February. You notice the bulletproof high pressure, this would be dry air moving into the Atlantic. That maybe would be the beginnings of the breakdown of the blockade over California, allowing precipitation into the state, especially as the active phase makes its way across the Pacific. And certainly when you get into mid-February, it looks like a big red X for precip into California. Unfortunately, that means, well, today's the 19th, so we're still 3 weeks out before any significant relief is forecast. We'll see. It's a model going out 40 days. Don't know if I believe it, but I'll take hope wherever I can get it. All right, so let's go look out a month now. Past performance here. This is the forecast down here. This is from the CFS model, another dynamic model. All right, here is today's date. This is east-west component of the wind. Stronger easterly anomalies generally associated with the inactive phase of the MJO. Westerly anomalies here. Maritime continent is like right there. This is the entrance right here to the Pacific. The date line right there. California's over here at 120. All right, so back in December, here was our active phase of the MJO. Yeah, the dark solid contour is the active phase of the MJO. With westerly anomalies, we had a whole bunch of surf right in here, and we also had rain associated with the Jetstream again, coming over here, whipping it across. Then we got into Christmas time, and things started falling apart. Weaker westerly anomalies. Here's our inactive phase of the MJO, currently now approaching the date line. Strong easterly anomalies forecast right there for about a week or so. But notice, just like here we go again. Strong westerly anomalies forecast as the active phase builds over the maritime continent. The easterly anomalies start weakening as we get into the first week of February. And this, I'm thinking, is when the jet stream would become active again. High pressure would break down off the U.S. West Coast, and we would have a shot at rain and snow, hopefully down into Southern California. Now, again, this is a guess on top of a guess on top of a guess. This is not a guarantee, but just sort of looking at this, generally, I would say this is probably our best shot at getting significant precipitation anytime soon. Then finally, the CFS model going out 3 months. Past performance is on the bottom. The forecast is up here on the top. Dateline runs right up the middle here, 180. Entrance to the West Pacific at about 125 east, so right there. Here we are right now, the blues, easterly anomalies, inactive phase of the MJ. You see it just for the next week, just locked down solid as can be. No wonder there's a 1040 millibar high forecast, in the East Pacific. This is not helping it at all. But then you also see westerly anomalies building. And according to this model, as you get later into February, again, I don't believe this, but a full-on westerly winds pushing over the date line, approaching California. That would be great if it were happening. Theoretically, another pulse of that in April, but I'm not even looking out that far. Let's overlay the MJO here. No big surprise. The dotted contour, the inactive phase of the MJO, pushing over the date line region, just starting today, expected to continue into about February 4th. So that's probably the lockdown period. Then here comes the active phase of the MJO in the West Pacific starting about February 4th and continuing in some fashion the whole way into early to mid-March, something like that. Now, this is over the date line. I'm not even looking east of there, but active phase pushing under California. In California's at 120 west in late February. Yeah, maybe, but it's showing that here too, and there's no rain. So I'm discounting that. I think all the indicator of where anything's going to happen, it's all based over the maritime continent and how it interacts with the jet stream. Let's overlay the low pass filter here real quick, just to get a sense of what's going on. This is the low pressure bias here. You see, I'll click this in and out, these last bit of contours here. This is if this were over the date line, it would be El Nino. But no, the low pressure bias is over the maritime continent, where all those westerly anomalies are, which feed the jet stream, which push it across the Pacific. In the central Pacific, though, over the date line here, this is a high pressure bias, the La Nina indicator. So even here back in December, we had 1, 2 contours. December's right in there, and we were getting rain into California. It's theoretically forecast in a couple of days to build with 3 contours. It's a little bit of a concern with that previous theory I was talking about. I mean, we'll just have to see. But I think if the jet stream is supercharged enough here, it's going to push right over all of that and at least help us to generate surf, but even more importantly, try to bring some rainfall into the state. We're going to move fast here. Subsurface temperature profile. Now we're getting to the El Nino, La Nina portion of the discussion. Yes, we know we're in La Nina. We think it's a Modoki La Nina. If you've watched the videos the past week, Modoki means it's like La Nina, but not really. It's like a weak La Nina, and instead of pushed up against Ecuador, it's out in the middle of the Pacific. We'll see that in a minute. But anyway, subsurface temperature analysis, effectively unchanged from last week. Warm water in the West Pacific, warm water in the East Pacific, but very shallow. It is the anomalies that really tell the picture. These are the differences from normal. Cold water in the middle of the Pacific on the equator, with warm water in the West Pacific, warm water in the East Pacific. This manifests itself at the surface as well. We'll take a look, one more chart here down below. Basically, same data. Yeah, you see it in motion here over time. This is your building La Nina pattern right here as we get into December and January. Not as strong, and notice, I was hoping this would loop through one more time. The expanse of the westerly anomalies building. I mean, here is the date line is right here. We already have warmer than normal temperatures building under the date line. So this sort of suggests that this is the last pulse of La Nina, and its demise looks to be setting up in the West Pacific. Let's take another view of this. Upper ocean heat anomalies. This is the West Pacific here. This is the East Pacific here. Over time, this goes back a year. Here is your pulses of La Nina cold water. These are water temperatures pushing across the Pacific. 1, 2, 3. They're like cold water Kelvin waves. 4, 5. Here's the 6th one, the strongest of all of them. But notice, in May, when La Nina was building, it was tucked up here along Ecuador. And then progressively, if you wanted to build a line where the center of the coldest water is, see it moving further and further away from the coast. And now it's basically south of Hawaii. Hawaii is like 150, 158. Here is our current 6th pulse, and it already seems to be fading to some degree. Not a lot, but it certainly is not eastward displaced. It's westward displaced over the Central Pacific. So it is the ocean surface that really matters, because the ocean surface is what interacts with the atmosphere above it. These are sea surface temperature anomalies, difference from normal for this time of year, and this is compared to a 30-year base period. All right, South America, Central America, Hawaii, the equator right here, the blues, colder than normal temperatures, and specifically it's this, not this that we're looking at. This is 5 degrees north and south of the equator is what affects the whole planet's weather circulation, and specifically the jet stream. And here see Ecuador. Warmer than normal temperatures off here. In fact, I was talking with one of our viewers was saying they weren't getting any rain into Ecuador earlier this fall. Most of their electricity is based off of hydroelectric. And if you don't have rain, the dams can't release water. They can't generate electricity. And I talked to another buddy of mine. He was just down there, and they're still going through daily power outages. Not as bad as it was back in the early fall, because apparently, notice water temperatures are warming. You get evaporation. Evaporation supports condensation and cloud production in this area. So Ecuador is still having power outages, but not as bad because they are getting rain and it's starting to flow into the rivers, and they're able to generate electricity. Normally, though, this is what we call the Modoki La Nina. The cold waters normally would be right here where this warmth is, right up along the coast in a classic La Nina, but no, it's limited out here. And typically when you get a Modoki La Nina, they don't last long. They don't have a lot of effects. Some of the effects I think we're getting are still hangovers from the Hunga Tonga volcano. We talked about that a month or two or three ago, pushing aerosols up into the atmosphere, supporting reflection of sunlight onto the ocean surface, cooling things down a bit. And when you end up with the average planetary temperature being colder, you get less precipitation and high pressure building up in the Pacific. I think that's definitely where we are right now. But anyway, here's your classic Modoki La Nina pattern. Sea surface temperature trend for the past 7 days. Again, South America, Central America, warming temperatures off of Ecuador the whole way out to 120 west. So this doesn't indicate any sort of La Nina thing building in the East Pacific. A couple little bits of cooling here, but also offset by equal warming. So I think our Modoki La Nina is probably at its peak as of right now, if not even fading a bit. Here is the sea surface temperature trend in the Nino 1.2 area. This is the area right off of Ecuador and the Galapagos. Over time, 0 is neutral. Today's value, 176 thousandths of a degree below normal. So practically normal. If you're half a degree above to half a degree below normal, that's considered normal. We've been normal theoretically since about Thanksgiving. And if anything, the trend line is maybe inching its way up a little bit. But the official El Nino monitoring region is the Nino 3.4 region. That's right out there, right in the smack in the middle where the Modoki La Nina cool pool is sitting. So this almost kind of overstates it. The value, minus 1.163 degrees. So half a degree is neutral. From half a degree to 1 degree is a weak La Nina. Moderate is from 1 to 1.5 degrees. But you got to be there for like 5 months. We've been there for about a month. Yeah, December 19th. So roughly from there to there. Yeah, so about a month. The reality is that we're still in what one would classically call a weak La Nina. The corrected Nino 3.4 sea surface temperature anomalies, again, in the official El Nino monitoring region, it's these values right here. And this is by week. So January 1st, the week of, we were 0.7 of a degree below normal, which is barely weak La Nina. Same thing, the last value, January 8th, 0.7 of a degree. And we haven't even been, I mean, again, you got to be half a degree below and hold there, and we've only been really in that territory since December 11th, where we've been just below 0.5 degree. So again, supports a weak La Nina conclusion. So what does the atmosphere think is going on? We've talked subsurface temperatures, we've talked the MJO thing, we've talked sea surface temperatures. The atmosphere above it is the ultimate determiner. So we look at the difference in pressure between Darwin, Australia, and Tahiti. If pressure is on average lower in Tahiti, the index goes negative. Well, it's positive today, 6.13. But you see we were negative for a couple of days, actually a pretty good run of days, about 16 days, I think, earlier into late December. That was likely driven by the active phase of the MJO. Okay, and then we go look. That's kind of noisy. So let's go to the 30-day average. Well, on average, we're below normal, minus 1.81. So still, that's basically neutral. That's not even La Nina. We'll go back. Oh, look at that. We were up at plus 13. That's definitely some like moderate La Nina back in December 23rd. But since then, we've fallen to basically neutral. So then we go out and look 90 days. Well, we're plus 5.57, so that's biased towards La Nina. Anything positive is biased towards La Nina, but where were we a month ago? 6.917, basically unchanged. We're in a weak La Nina state, according to the Southern Oscillation Index. Let's look at it on a graph. Here's a 30-day running SOI. Neutral, according to this, is +7, -7. This is out of Bureau of Meteorology, Australia. And you can just see, well, neutral, 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 neutral. We almost went to La Nina in December, and now today as dead neutral as you can get. So according to this index, we should be not even La Nina, but clearly anybody that knows what's going on based on high pressure off the U.S. West Coast and sort of the jet stream pattern and this continual offshore flow, that's classic La Nina in California. The PDF sea surface temperature forecast for the Nino 3.4 region from the CFS model, you can see we were in El Nino last year. Sea surface temperatures up at 1.5. I think they were up to nearly 2 at one point. Slowly fading. Once you get below half a degree, you're in weak La Nina status. Here's the solid contours actuals, the dotted contours forecast. This says temperatures dropping to 1 degree, but in February or early February, don't think that's going to happen. I mean, this model has overstated that. Regardless, after that, it shows temperatures heading right back up into neutral status and warming slowly as we get into next fall. Let's go look at some other practical impacts of that. Sea surface temperature forecast from the same model. This is for February, March, April. You see South America, the United States, Australia. This is the equator and the date line. Cool temperatures. This even shows them broader here than what's actually happening, and that's slowly decaying as we get into April, May, June, and July. So a decaying La Nina pattern. I think this is probably even overstated. And then the all-important precipitation anomaly forecast from the CFS model. So this is for the month of February. They're showing much more rainfall than normal up in the Pacific Northwest, as one would expect, and bone dry into Southern California. Now, that doesn't mean no rain, but much less than normal. Now, interesting here, as you get into March, notice they're saying not bone dry anymore in Southern California, just neutral, and rainfall building. I mean, we talked about this last week a little bit, that perhaps it's a late winter that's going to come. We'll see. I don't know if I believe it just because one model says it. Anyway, into April, again, rainfall pattern still really focused on the Pacific Northwest. And then after that, it really doesn't matter. Also notice the bone dry pattern over the entire southern tier states of the U.S. the whole way into April and May. That's classic kind of La Nina. So we're in La Nina, maybe not completely, but from a rainfall perspective, absolutely. All right, so let's put a quick bow on this. Surf-wise, well, we have piles of surf in the water. It looks like there's going to be surf for almost the entire week. Next weekend, things start falling apart as the jet stream pattern falls apart. No big surprise. That said, looking longer term, we suspect westerly anomalies feeding the jet stream as we get into the first and maybe 9 days of February. And then I would expect the jet stream to build, the surf pattern to increase again. And then as we get deeper into maybe second week of February into mid-February, that would be when I would expect to start seeing precipitation return again to California. Again, a best guess. I would not bet on it. Do not hold me accountable for that. It's just my best guess based on what happened in California back in December when we had rainfall. I seen that same sort of pattern trying to set up again. Whether it actually will happen or not, I don't know. It's our best guess. Then before that, though, high pressure locking things down as dry air moves south of California for the next 2 weeks, probably week and a half to 2 weeks. And so we got to take our lumps, and the surf will probably fade as a result of that as well. But come later in February, certainly into March, I think we're going to be into a much better place. We just have to have patience. I know it's really hard, and especially for the folks in Southern California. My heart goes out to you. I just can't imagine the situation that many people are in there. And with more Santa Anas coming this week, be on alert, be vigilant, and do your best, and do what you got to do to take care of yourself and your families. All right, that's our video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, subscribe down below. Click the Stormsurf icon down the lower right-hand corner of your screen. If you have a question, you don't understand what we've talked about here, just write it up down below. I'll be happy to answer. And then if you'd like to make a small contribution to the cause to keep us going, to keep these videos going, use the super thanks button down below, the heart with the dollar sign in it. We do appreciate all your contributions. And with that, we're done for this week. We will do it again next week. Same time, same channel. Thanks so much for watching.